Now we got Johnson, Arnold, and Flint, radiocarbon dating, Science magazine. The problem of atmospheric contamination by fossil fuels has also come in for some consideration. Since the burning of coal and oil during the past century and more has added measurably to the amount of carbon dioxide in the carbon style. This means that the standard figures as to the present condition of carbon dioxide in the exchange reservoir of carbon on which the radiocarbon age calculations are based are incorrect with respect to conditions under which older specimens were formed and have since been decaying. Although this might be corrected approximately by modifying the standard to one before the Industrial Revolution, the following caution is also in order. Since completion of the present list, a careful study has been made of a series of samples of known age. It was found that the activity of radiocarbon in the atmosphere was going up and down even before the Industrial Revolution. Here we have DeVries and Waterbork and their study. Dr. Donna R. Patton says, probably the radiometric dating system that receives the most attention is radiocarbon, though it's probably less significant for evolution creation controversy than any other because it covers such a short period. Nevertheless, there are clear indications regarding radiocarbon. There are serious problems, and without going into the particulars, notice a quotation from Robert Lee from the Anthropological Journal of Canada. He says, the troubles of the radiocarbon dating methods are undeniably deep and serious. Despite 37 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged. Now, this is not a matter of contamination or something that happens to be added. This is the underlying assumption, the basic mechanics of the system. He says it should be no surprise then that fully half of the dates are rejected. Now that's the authority that uses it, that believes in it, at least to a degree. We check at least half of them. And I have found from my experience that that's a conservative estimate. For example, Martin Lubenow, in his book Bones of Contention, has about 3 chapters on the dating controversy that involve the skull number 1470. Of course, not dating the skull itself, but the layer above it, the volcanic tuff. He points out that the dates they got were way off. The ones they got later they assumed were correct, but they later found that they wouldn't fit with the evolutionary theory, and so they redated and redated. Science? They dated 41 times. And we're talking about the scientists at Cambridge University. Hopefully they did that behind closed doors and windows. Supposed to be the most accurate in the world. They chucked the first 40 efforts and kept the 41st. Well, that's not a scientifically dependable process, you think? You're just getting what you assume to be, so to start with. And so we understand that Lubenow goes on to say, the wonder is surely that the remaining half come out to be accepted. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates, not accepted. Now that's the truth. It's not that this is what the evidence demands, but it's what they pick out of it, a wide range of what that sorts, what they assume to be the case to start with. We've done some radiocarbon down at Glen Rose, Texas, in the area where I've been working in recent years. there's wood in the formation supposed to be 110 million years old. But this wood fragment from that formation, dated by radiocarbon at UCLA at 890 years, less than 1,000, in a layer supposed to be 110 million, just a little bit down, about 100 yards from that, in an area that we'd excavated. We'd be taken the overburden off. We got to another carbonized stick. We dated it at the UCLA carbon-14 lab, and this dated 12,890 years. Not too far away from the same formation at 890. Now that's a huge difference. All in a layer supposed to be 110 million. We've excavated 2 dinosaurs from that area, dated at UCLA radiocarbon lab at 19,000 years, in a layer supposed to be 110 million. We dated now 19 different dinosaurs, not supposed to be any radiocarbon at all in dinosaur bones. They've been extinct for over 65 million years, we're told. And carbon-14 plays out in a few thousand years, 30, 40, 50, 80, some might say. Well, we found it in all of the dinosaurs we've dated, all 19. The ages rate from 10,000 all the way up to 30,000 and everything in between. Obviously, something is seriously wrong. You think? Is this high school science? We notice a statement reported in Science on an international conference of 145 experts in the field, and they say throughout the conference, emphasis was placed on the fact that laboratories do not measure ages, they measure sample activities. The connection between activity and age is made through a set of assumptions. One of the main assumptions of C14 dating is that the atmospheric radiocarbon level has held steady over the age range to which the method applies. In other words, we got the same amount of carbon-14 now than we had when this critter died that we're trying to date. However, we have seen clear indications that that is not a valid assumption, as we see the ages varying drastically. We know that's not the case, in fact, because the level of C14 has been measured to be increasing. It was thought to be at an equilibrium. If we use the analogy of the faucet pouring water into a tube, that for the sake of illustration we'll assume to be infinitely high, as this column of water increases, then the weight of water would increase and would force the water out faster at the bottom. Now, when the rate of flow at the bottom increases to the point where it equals the rate of formation at the entrance at the top, then we have the level remaining constant. It would stay the same. If you have as much water flowing into a laboratory as flowing out, then the level is going to stay the same. We have measured and found that the C14 in the atmosphere is 30% short of equilibrium. Now, this has been done at UCLA and a number of other places, and by Lubenow himself. Lubenow's original work, for which he won the Nobel Prize, determined that it would take less than 30,000 years to reach a state of equilibrium. However, it's 30% short. Now, this is not a linear process. It's an exponential process. It slows down as it approaches equilibrium. And you can calculate how long it would take to reach the present level. And it comes out to be something less than 8,000 years old. That certainly fits the picture of the creationists and the young age of the Earth much better than the evolutionists. If it only takes 30,000 years to get to equilibrium, and it's not there yet, I think we can see very clearly that what the straightforward facts indicate. And when you can calculate how long it would take for it to get there to where we are, and we see a few thousand years, then obviously there's a good reason for radiocarbon to say the Earth is only a few thousand years old. You must make a number of assumptions contrary to what we observe in order to get it to come out old. Now, we can make assumptions that rates remain constant and that the observations we make hold true over a few thousand years, and that the process is really scientifically more valid than if these rates were assumed as remaining constant over billions of years. And when we do assume a constant rate over a very short period of time, with a number of indicators, we see a very clear indication of a young Earth, a young age for the young Earth. Compare a quotation from Dr. Patton's notes. H.E. Seuss, UCLA, presented the latest determinations as deduced from the current activity of chronologically dated growth rings of the Californian bristlecone cone pine. The carbon-14 concentration indicated that the concentration increases. H.E. Seuss, another comment. Therefore, the content of carbon-14 in organic matter is still on the increase, not having reached equilibrium yet, which takes an estimated 30,000 years, testimony to a young Earth. We have pre-flood period carbon-14 proportions not factored in. Prior to the flood, it is highly probable that the ratio of ordinary carbon to radiocarbon in the atmosphere was much higher than at present, mainly because of the global semi-tropical climate and the vast amounts of plant life found around the world. This effect would have been augmented by the smaller amount of carbon sustained in the ocean than now, since the oceans were smaller and the land areas larger before the flood. And it is possible that it would be still further augmented by the shielding effect of the thermal canopy, which would have inhibited the formation of radiocarbon in the high atmosphere. All of these factors would have reduced the ratio of radiocarbon to ordinary carbon to a much smaller fraction than now obtains. Another possible effect of the canopy is very interesting. In addition to the formation of the carbon-14 from nitrogen in the atmosphere by cosmic ray neutrons, these neutrons also react with deuterium, heavy hydrogen, the hydrogen isotope in heavy water, which would undoubtedly have been present in substantial amounts in such a canopy to form tritium, a still higher isotope of hydrogen. Tritium is unstable and decays rapidly by a beta decay to an isotope of helium, He3. But it turns out that there is too much helium-3 in the atmosphere to be accounted for by this process operating at present rates during geologic time. The Cosmic Ray Authority, CORF, suggests the following solution of the problem. There are two factors which would tend to increase the amount of tritium. One of these is that the intensity of cosmic radiation, and hence the rate of production of neutrons, might have been higher at some time in the geological past. The second possibility, invoking action in the past, assumes that at the time when the Earth was warmer, the atmosphere contained much more water vapor, and the process of generating tritium from deuterium might have been operating at a much higher rate than at present. Sarah J. Karff. The canopy thus not only provides an explanation for the present excess of atmospheric helium-3, but also implies that the proportion of cosmic ray neutrons reacting with nitrogen to form radiocarbon would be smaller by the amount reacting thus with the hydrogen. This factor combines with the other mentioned to assure that the percentage of radiocarbon in the radiocarbon dioxide of the antediluvian atmosphere must have been much smaller than at present. Therefore, the radioactivity of living organisms ingesting this carbon dioxide.